but my teammates are out in Washington, D.C. So we're close, no matter what time zone you're in. It's great to be here with you. Jerry and I are going to give you a orientation to the two cockpits in this airplane. Jerry was a pilot, and I was a backseater, better known as a reconnaissance systems officer. So now that the lighter entertainment is complete, Jerry's going to do an overview, and then I'll talk a little bit about the back seat, and then Jerry will pick it up from there.
Okay, guys, I'm Jerry Glasser. I was very blessed. I flew John's first sortie, and it was my final sortie in the airplane. Very emotional sortie. We're going to do, there's 4 people. John and I will do Saturday. B.C. Thomas, he's the high-time pilot in the program. Unfortunately, his backseater is deceased, but Barry McKeon is going to do the Sunday presentation. And it'll be roughly the same. There's John and Terry. Terry was just in the presentation this morning, and that's all done before we dyed our hair. There's Jerry and Mac. That was my first backseater. I was very blessed. I was an instructor. I flew with 13 RSOs, meaning from an instruction standpoint. It was a real pleasure. Everybody had their idiosyncrasies, but we were so privileged. You're not going to find an egotistical SR-71 pilot or RSO. We were really blessed to be knowing that we were selected. We didn't know why sometimes, but you know, it's the old Gary Player syndrome. Why are you hitting 3,000 golf balls? The harder I work, the luckier I become. And we were pretty blessed. We were pretty blessed. There's BC and GT. JT Vita was the high-time RSO. He's no longer with us. And BC will be in a panel, but he is also a test pilot, flew for United Airlines. He's the guy that took the airplanes up and made sure they worked. And he's a good buddy. He was my instructor and drove me crazy. You hate your instructor until something goes wrong. And then guess what? You love him. You just love him. Okay, where's Barry? I don't think Barry's here. We don't have a color shot of that. Look at that bird. Come on, guys. It's awesome. 1963.
Whoa. Awesome.
1963. And when you look at this propulsion system right here, from an inlet to an engine to an ejector system, and supersonic flow is very difficult to manage sometimes and instruct. But the propulsion system is now 60 years old. We have not built a propulsion system that can go beyond Mach 3.5 and sustain. We've been trying to do it for 25 years. We've been unsuccessful. Oh, I just went Mach 7 for 2 minutes. Where's the piece of junk? It's in the middle of the Pacific Ocean. I've flown Mach 7 for 80 seconds. Wow, where's the piece of junk? It's in the Pacific Ocean. This is the only bird that flies for 1 hour and 10 minutes at Mach 3.2 and says, I think I'll do it 4 more times. And comes home and says, what's the problem? I don't know. A couple of circuit breakers, unstart. Yeah, everything worked. And what year is it? 1963. That's just amazing, absolutely amazing. Okay, what we're going to do, John's going to go through the back seat, and this is my sensitivity. When I say conductor, I mean that very sincerely. I treat the pilot as the first violinist in an orchestra. John is the conductor. John's the person in the back, and they don't get enough credit. But he's the person, John and other RSOs, he's the person that manages the mission. He's keeping things on track. He's got the big picture. When I get a little confused in the front, and I've made mistakes in the front, and I know John's made mistakes in the back. But the goal is for not 2 of us to make the same mistake at the same time. That's it. Because you're going 35 miles a minute, and when you're lost at 35 miles a minute later, you're 35 miles further away when you don't know where you are. You know? But I think the thing is that the RSO is this manager who's orchestrating the mission. The front seat is so busy with dials and inlets and stuff and temperatures that the back seater keeps things on track. When I'm behind the tanker at night, when I think I'm in a 90-degree turn and John's saying, Jerry, we've got 5,000 more pounds to go, you're straight and level, you're doing a great job. And I'm sitting there saying, yeah, I'm doing a great job. But that's the person who's the conductor. And they really need a lot of credit for that. I'm the first violinist. I just keep the pointy end forward. That's it. I'm keeping the pointy end forward. Okay, you're going to forget most of this. Don't forget these slides. This is the key. We, crew members, rented the airplane. We were just Hertz renters. Maintenance owned the airplane. And they were the very best of the best. Any 135 drivers here? Raise your hands. Anybody? Without these guys, thank you. I love you. I absolutely love you. I don't know if you're a crew driver, but a 135 driver? Okay, there you go. Okay, KC-10s, we love them too, but 135. We have never missed an operational air refueling, ever. In 20 years, every place in the world, every single time. Rolls out right in front of you 2 miles, and there's 70,000 pounds of gas waiting for you every single time. And that's the beauty. There it is. We didn't complete our mission without 135s. We were worthless. We were kids on a totem pole. We can go 1,500 miles out and 1,500 miles back if we didn't have a 135 to give us 70,000 pounds of gas. There's the new cockpit of the SR-71. Oh, come on, guys, it's a joke. You can laugh, it's okay. Anybody know what that is? Anybody? If you get to the Evergreen Museum, that's the spruce goose. That's the spruce goose. Yeah, sit in that thing. We've been up there. It's an amazing. You look behind yourself, and there's a 360-gallon oil tank sitting behind the cockpit, feeding all the engines. You're urinating 360 gallons of oil coming out of the engines. I said, what's that tank back there? He said, it's filled with oil for the engines. It's amazing. And you know, if you go there, they got a hat, you can sit in the cockpit, put on the Howard Hughes hat and sit in the cockpit, but that's it. Okay, this is the A model, not the B model, so Jerry and BC will be in the front, and John and Barry are in the back. That's the front seat. We don't have a good one in the back seat, I'm sorry. But the thing is, that cockpit, that little windscreen, we call it a pie plate, where about 60% of your visibility comes out of, that gets to 610 degrees at speed. You can take your glove and touch it, not for long. Right in front of you, the front windscreen is 610 degrees at speed. How do you clean your oven? About 500? Raise it 110 degrees, and that's the front part of this airplane. Okay. There's the front seat, and John is going to take care of the back seat. But before we do that, I'll give it to John. We're going to hand these out. Please treat these carefully. Would you take the bottom one? Would you take the bottom one? Thank you. Okay. This one is the RSO. This is the Bible. This is our Bible. You don't memorize this, you're not going to fly the airplane. These are the both checklists. So just take a look and just be gentle with it, please. Could you do it? Okay. Secondly, you got about a minute and a half to memorize it. You're all going to grab this. This is the stick of the SR-71, and you can't tell how many engineers we have in the audience. Come on, raise your hands. You can't, I'm not criticizing there. Okay. We both have dyed hair, right? Okay. Yeah. You can't tell an engineer that the stick is telling you it's feedback. I don't have to look at the gauges subsonically to know what the airplane's doing. This stick, it's a cable airplane. This stick is providing feedback. I know exactly what the airplane's doing. Oh, I look at the instruments. But if you tell an engineer the stick is telling me what's going on, they go, huh? That's the problem with side stick controllers, with electric controllers. There's no direct feedback. There's no cable feedback. There's a cable from the front seat, 105 feet to the back seat, 2 cables that fly this airplane, and the cables provide feedback. And I'm going to explain this, okay? I'll let you just take this and look at it. Okay, we have a special guest in the audience. Her birthday is today. Ready? Happy birthday to you. Happy birthday to you. Happy birthday, dear. Whoever, happy birthday to you. Okay, now, I want to show you the difference, how the stick works, okay? The husband is the back, going to punch me in the nose, but okay. Okay, ladies, the stick is a woman, and you're dancing. some males are dancing with a lady. Isn't that true? They're going to maul you, right? This is the stick. This is the stick. It's a waltz. It's a beautiful waltz. And I don't have to tell her anything. I can push her, pull her, and she, not a word is saying. Not a word is saying.
Can't hear her.
Thank you. Happy birthday. Happy birthday, seriously. But that's the stick. The stick is just a waltz. And subsonically.
Use a microphone, please.
There's no microphone.
When I grow up, I'll let you know. But when you
Start over.
when you fly the airplane subsonically, it's a beautiful airplane to fly in the pattern, and the stick is vibrating and telling you what to do. And I'm saying that's the only demonstration I can make. But you can't tell an engineer that that is really happening, because it's nonverbal. You don't have to tell the dancer to twirl. You don't have to tell the horse to prance. It's all nonverbal, and the stick is our nonverbal communication. Okay, so John is all the goodies. I keep the pointy end forward. He's the guy that does all the work. And when he's busy, I learn to shut up, and he's taking the take. But you're going to be really fascinated with the back seat, because what year is it? It's about 1964, and wait till you see what's in the back seat. John.
Thank you, Jerry. And good afternoon once again. It's a pleasure to be back here at March Field. Thank you. This museum holds a special place in my heart, and coincidentally, my primary pilot, Terry Pappas, is attending this symposium as well. And it's important to both of us, because we actually delivered this airplane to this museum in 1990. As we were shutting down the squadron, we were handing out the airplanes per congressional direction to various museums around the country. And we were based up in Northern California at Beale Air Force Base. So our very last flight in the airplane together was to hop this down here and drop it off. And there's some pictures around the museum of the day we did that. It was rather a nice welcoming ceremony, and a lot of fond memories. And coincidentally, there was one other occasion important that made this airplane important to us. We, in the late 1980s, were selected to fly one of the very few very long missions the SR-71 flew, from Okinawa, Japan, to the Middle East and back. We covered 12,000 miles in about 11.2 hours. And it's a good story. It's for another time, but 975 is really means a lot to us. So I'm really happy that Terry and I, this is the first time we've been here together since we dropped the airplane off in 1990. And it's a great symposium for me as well, because for the first time my wife Tracy has accompanied me to this symposium, and pleasure here. And I'm looking forward to the critique after I'm done here. Okay, so I'm going to talk to you about the back seat. And like some other aircraft of the era, this was a two-place airplane, as Jerry explained, a pilot in the front. And somebody in the back like me came out of either bombers or fighter aircraft, typically. There were others. But we were accustomed to being either behind a pilot or to the right seat of a pilot, like I did when I flew F-111s initially, and then later the RF-4. So I had a great preparation, and was fortunate enough to get selected in 1985 to come fly the airplane, and did that until we shut the squadron down in 1990 as we dropped this airplane off here and some others elsewhere. Okay, so one thing that helped me out in the late 90s, there was a movie release in 1986, you probably heard of it, Top Gun, and now of course it's been a sequel after many years. The reason we like Top Gun, because even though it was Navy, it really showed what it was like to be in a fighter aircraft of the era, and in particular a two-seater airplane. And that helped me out because people generally understand what pilots do. It's pretty universal, no matter what airplane they fly in. But this person in the back, not quite clear. After Top Gun came out, it became pretty easy for me to explain what I do. I just asked if they had seen the movie, and did they remember Goose? And then I had many fewer things I had to explain. So it's convenient to have that at the time. All right, so what is the person in the back doing? Well, in this case, we're a all-weather, day-night type reconnaissance aircraft. That's what the SR-71 did. So while this flew at extraordinary speeds and altitudes, the mission was similar to what I did in the RF-4, for example. We were out collecting intelligence on various points around the world, almost anywhere around the world, actually. So what was a little different about this airplane is that while the pilot is in the front, the RSO, as you're known, in the back, our job is totally systems oriented. And I'm going to explain a little bit about that. This rather nice looking cockpit is actually the view of our simulator. We had a fantastic simulator, especially for the era, to train both the pilot and the backseater. As you look at this, and I'm going to tell you a little bit about what I did, or anybody who got the happy occasion to fly in the backseat of this airplane, we actually had a handful of responsibilities in the back. Pilot was pretty straightforward, as Jerry said, keep the airplane pointing and going forward, make it go fast, make it go high, and keep us all cool while we were doing that. In the back seat, my responsibilities were, first of all, navigation. We were trained as navigators, first of all, not pilots, we were navigators. So we held primary responsibility to keep track of where the airplane was, and more importantly, where it was going at about 33 miles per minute. In addition to that, the mission, of course. As I said, this was reconnaissance, so most of the controls and indicators for what our various kinds of sensors on the airplane doing were in the back seat. But in addition to that, just like any other airplane, both people on an airplane are responsible for and very concerned with how well the airplane is flying, and that's being flown safely. So we function in some ways as a co-pilot, and that involved things like running checklists. Jerry is passing the checklist around, they're coming your way. The pilot normally did not spend any time looking at a book while flying this airplane. We held responsibility for making sure we were accomplishing all our checklists, both normal procedures and emergency procedures. But even more important than that was keeping track of the configuration and the performance of the airplane. By that I mean, was it flying in the right attitude? Was it the right speed, Mach number, altitude, things like that. And over the years, they added more instrumentation in the back seat so we could keep an eye on things. It's called a safety of flight observer role. Literally, we want to make sure the airplane was performing properly and back up what the pilot was doing. The fourth primary role was communications. A lot of the communications were handled from the back seat. We had all kinds of radios, and I'll talk to you about that in a little more detail. But we had the ability to communicate line of sight and also over the horizon with the high-frequency radio. And we had some other specialized communications equipment to make the mission run properly. And then last but not least, electronic warfare. This airplane was designed to theoretically replace the U-2 because the U-2, being also high-altitude reconnaissance airplane, was subsonic, and it was more vulnerable. And I think everybody knows the story of Gary Powers in 1960 when he was finally shot down by the Russians. Before that, they were already designing this airplane because the CIA, who bought the original version of the airplane, the A-12, and Lockheed knew that the U-2's days were numbered and was not totally invincible. So the way to solve the problem was, same idea, go high, but also go very fast to be a very, very, very tough target. And in addition to that, make a stealth airplane while you're at it. It's unbelievable how many challenges this team faced to make this airplane viable to fly against any threat of the day, surface-to-air missiles or air-to-air missiles. So, but the additional concern was that even with all that, they did not want to take the chance that any radar-guided or infrared-guided missiles could still do harm to this airplane. They had state-of-the-art electronic warfare equipment in here, and we maintained that and operated from the back seat. Okay, so some basics about the cockpit. This is true of any cockpit, pilot cockpit or a systems operator cockpit. The things that are right in front of you and most easily accessed are some of your most important instrumentation. And this is no exception. There's a combination, and we'll talk a little more detail about this, but a combination of aircraft performance information here, how's it flying, how we doing with fuel, that sort of thing. And then some of our primary reconnaissance displays. We made good use of what is a fairly tight cockpit. Most high-performance aircraft cockpits tend to be smaller because you want the airplane to go fast, so you keep the profile of the airplane narrower. So we on both of our panels on either side, we had various combinations of, on the left side, both navigation and communications information, 2 of the 5 things we're concerned about in the back seat. And similarly on the right side, more navigation and then sensor controls, the primary reason for flying this airplane high and fast. Okay, some interesting things about the airplane. First of all, it's a tandem seat arrangement, so not unlike an F4 or F-15, we have 2 people in the airplane. Sometimes you're able to see the front cockpit and you can look around the pilot's head a little bit. If you really want to get his attention, you can knock him upside the head and say, hey, pay attention to me in the back seat here. This airplane, totally different. This cockpit was added to the original single-seat airplane. And when they did that, they basically walled it off. It was completely separated from the pilot's cockpit. So, in other words, we were totally dependent on an interphone to talk to each other. And that was fine because we all came to this airplane very highly experienced. Pilots had already accumulated more than 1,500 hours of flying time. We in the back seat had to have at least 1,200 hours to even apply for the airplane. So working on interphone and after a year of training in this airplane, we were more than ready to operate that way. But something you might notice missing here, actually a few things missing here. I mentioned I had some co-pilot responsibilities. Well, if you look at this cockpit, what's not there?
Stick.
No stick, no throttles, no rudder pedals. You could not fly this airplane from the back seat of the A model. We had a special trainer where the pilots got trained in, but the mainline airplane here, I was along for the ride and totally dependent on what was going on in the front seat, or was keeping the airplane flying high, fast, and straight. But we were totally confident. I'll tell you, without exception, some of the absolute best pilots in the Air Force were flying this airplane. The program was that selected. And it was, compared to some of the things we were doing in our earlier careers, this was just the creme de la creme. Okay, so I'm sorry, I skipped the view display. This is something related to the fact that you really can't see anything forward in the back seat of the airplane. You can look out these side windows. If you look at the canopies over here, you notice the pilot had a combination of windows on the hatch as well as the pie plates as Jerry was describing it. Back seat, we could look out on either side, right or left, but that was about it. They gave us a view sight in the back seat, which actually enabled us to look down through the bottom of the airplane. So we could actually see the ground underneath us. As navigators, that was another opportunity to keep track where the airplane was and maybe update your computers if that was ever necessary. So that's the view sight. This screen that's folded up at the moment in the middle, the map projection screen. So try not to laugh. And I know those of you who are my era might have an idea of what a film strip was and the rear projection kind of display screen. We actually had a map that was photographed of depicting our ground track. And in flight, this thing will flip down, I'll show you that in a minute, and would actually, through a rear projection type arrangement, display the map with the ground track of where we're flying in the world. And it's good for orientation, just to keep yourself situation aware of where you were, and as long as you're on your black line ground track, everything was good. And the pilot actually had a smaller version of that in the front seat. Okay, so this is, screen's a little small here, so I'll verbalize what you're looking at. Over here on the right side, I've drawn an ellipse around the right panel, the right side of the front cockpit. And this is where most of the flight performance information was. So I'm thinking, is the airplane going in the right direction? I mean, are we in the right attitude? Are we flying at a safe speed, Mach number, and so forth? And like when Jerry's talking about air refueling, I was actually managing the onboarding of the fuel and so forth. So flying the airplane types of instrumentation over here. At the very top, there's a UHF. Let me see if this is laser will work here. Not really. Okay, at the very top of the stack up there, there's some counters, and these are old rotary type displays. It's a 1960s airplane after all. One unique thing about this airplane is when we flew operational missions, we didn't talk to anybody. There were no radio transmissions. We didn't advertise when we were taking off. That was the whole idea. We want to basically appear on scene with anybody being able to prepare for us. So without radio transmissions, how do you get together with your airborne tanker? Well, we actually had an encrypted signal that would be transmitted back and forth to the tanker, which would enable our two airplanes to find each other in good weather or bad. And that counter was giving us a indication of just how far away we were from the tanker. We started our descent from 80,000 feet, about 250 miles behind the tanker. So at our kinds of speeds, you know, big numbers for distance were not uncommon at all. But we had to come down to about 25,000 feet, find our gas station in the sky, and without ever transmitting a verbal communication over any kind of a radio, we would be pointing right at the back end of the tanker and fly within a mile of them and know exactly where they were. After hooking up to the tanker, we could actually talk to them on the interphone, but we would never reveal our position by actually talking on the radio to do that. Okay, other things that are there, so it was distance and a bearing distance. Heading was basically pointing out the tanker, and I would verbalize this information to the pilot and get him close to the tanker. A triple display indicator indicated when you're flying supersonic, traditional aircraft, a lot of traditional flying type instruments don't work very well. Things change when you start going supersonic. So we actually had computed airspeed and altitude and Mach number, a thing called a triple display indicator. And Jerry's going to have some more, a bit larger pictures of that, because these are the primary instruments that the pilot is flying off of. We had a good old 1960s clock over here, good old analog, not one of these, good old analog clock there, nothing else. You keep track of your time, and we're not dependent on any outside sources for that. Fuel quantity, this airplane has multiple fuel tanks in it. Basically, virtually the entire fuselage behind the cockpits is all fuel, and in between the nacelles and the fuselage, also fuel tanks. 80,000 pounds of gas for an airplane that weighed 60,000 pounds. So we held more gas than the airplane weighed empty, because we needed enough range to get where we were going to go. Okay, some of the things, and you'll see more here in another picture, but there's some boxes here right near our knees, which would actually present some of what the radar sensor would collect when we were flying those kinds of missions. So I mentioned it's an all-weather, day-night reconnaissance airplane. So during the day, it's obvious you can take really high-resolution pictures from this aircraft, either looking out the sides. There's a little window over here on the side of the airplane, but as you can see it underneath the right chine, that was where one of the cameras was mounted. So we'd have one of those on each side. They were framing cameras, think like 35 millimeter, big swath of land, very high-resolution pictures. The nose of this airplane, another ingenious part of this design, the nose is actually detachable. So they could pre-mount certain kinds of sensors in the nose, and one would be a camera, an alternate would be a radar. So some of the nighttime and bad weather collection came into play. So they popped the nose off, figuratively speaking, roll a different nose up, attach that, and you go from a daytime to a nighttime type collector. So while they're solving all these other problems about keeping this airplane, well, first of all, making it capable of flying the speeds and altitudes it's at, they thought, wouldn't it be nice if we just detach the nose and put a different sensor on the airplane and much more efficiently integrate and then replace sensors on the airplane. Just genius at work there. Okay, over here on the left side, staying with the front for a moment, some other kinds of indicators are very important to us, not the least of which was a center of gravity indicator. Controlling the center of gravity of this airplane had a lot to do with the way the airplane performed, and of course performed safely and efficiently. These were ways, one of the things the pilot was doing when we were on a mission was making sure we're getting the best gas mileage we could. And interestingly, about an airplane flying Mach 3, most fighter pilots are concerned about that because how fast you're burning gas. This airplane actually is most efficient flying Mach 3. It gets its best mileage going over 3 times the speed of sound. So some camera information here. I mentioned these side mounted cameras. They can actually be tilted from 0 to 45 degrees. So if you visualize that, if you're interested in something fairly close, you're pointing down at a lower angle. If you're trying to get way out, as we often did flying peripheral missions around countries we would not overfly, you can look further and further into past their international boundaries and into their countries. Again, a little hard to see. I'll point to it. There are 3 lights there. One looks kind of orange and the other 2 look red. These are kind of important. I mentioned we only talk to each other on interphone. So these lights were kind of an emergency way to communicate, for the pilot to communicate to the backseater. So orange meant alert. It actually said alert on it. That means I can't talk to you over the interphone, so pay attention. Something's going to happen here, maybe. The one on the far right said bail out. Now that was a message to me that it's time to get out of the airplane if something's really going bad, and I can't tell you over the interphone. So that was important to know, because if I saw that light, I was going out. The one in the middle said pilot ejected.
You don't want to see that.
Not a joke, it's really, because I would want to know that, of course. If the pilot ejected, I'd probably want to go too. And as well supported this airplane was by the U.S. Air Force and, of course, Lockheed and their subcontractors, this airplane flew for 17 years between accidents. We never lost an airplane in 17 years, right up until the end of the program, ironically. Couldn't have been helped. The crew lost all of their hydraulic systems. They were trying to limp back into the Philippines and get into a recovery base there. It didn't work out, so they had to leave the airplane. Well, guess what happened? The pilot went first. And then our friend, still our friend, fortunately, he's here, was in the airplane for about 3 seconds by himself. The only backseater to ever log solo time in an SR-71. Okay, a little better look at those lights. All right, so the view side at the top, I mentioned this matte display screen here would fold down out of the way. It's kind of like a tray in an airliner. Sit down here near your lap and you can watch the film, project your path of flight. In the middle, another screen, that's where you could actually see what the radar mounted in the nose was collecting. And this is not like a weather radar, this is a ground mapping radar. It brings back very high resolution images of things on the ground, which we cannot get with a camera, of course, because it's either used at night or in the bad weather. And to be able to see what's happening there, it was telling us the radar was working, it was collecting good images. We're not seeing at the same resolution as the intelligence analysts would see, but we were, we'd be quite concerned if we weren't seeing anything displayed on that screen while we were going. So it's called the radar correlator display. And that big box in front of our knees was basically the processor that would present the images to us in the cockpit. Okay, so I'm going to kind of wind things up here, just going down to the side panels. And when you're in a spacesuit, effectively, it was technically a full pressure suit. It's kind of bulky. The whole package weighed about 50 pounds. So it was rather bulky. And looking at things in front of you, not so bad, but down here on the panels, you have to do a little bit of work. You have to spin your helmet this way, look down or pull down sometimes. So, but you got used to it, and you had to because you had some really important controls here on the left side. Navigation computers. We actually had a secondary inertial navigation system over here on the left side. It was a very high quality one, but it was considered our backup because we had a much more interesting and capable navigation computer on the right side. Various radios and interphone control panels and so forth over there. Here's a little bit of a zoom in of that. I mentioned the UHF modem control panel. I'd set in a code there, and the navigator on the airborne tanker would have a similar code, and that would enable this encrypted signal to go back and forth between our airplanes and help us get together for an air refueling. The black panel there, which has nothing, is where our defensive control systems were mounted. This is how we detected threats, either ground-based or air-to-air threats. In other words, missiles that could be shot at us. And like most combat aircraft, you have a way to project electronic signals, try and confuse or distract the missile so it would not find you. Those systems are also classified when we retired the airplanes, so they pull the boxes out, and that's why it's a blank panel there right now. Interphone and radio control heads and so forth, the inertial navigation system here. And I know they all look like just a bunch of buttons, but after spending 5 months in the simulator before they'd ever let us in the airplane, literally 5 to 6 months in a box to earn your way to fly this airplane, you need these things inside and out. So over on the right side, I just want to tell you about my good friend R2-D2, who flew in the airplane with us. Behind the rear cockpit, and I'll show you a better picture of it here, is a bay where our astro-inertial navigation system is placed. And I'll show you a picture of that here in a second. This is the control panel for it. It's got a lot of buttons and indicators and so forth. And this was our electronic brain for the airplane. Now, again, this was 1960s technology. It's pretty phenomenal that you could develop not just an inertial navigation system. Inertial navigation systems keep track of your position because it has accelerometers and this gyro-stabilized platform. Once you align it with a point on the ground, it does a pretty good job of keeping track of where you're going after that. All INSs work that way. What's special about this one is that on top of that arrangement, they put a telescope. And that telescope did what I learned to do as a nav student a long time ago, was to shoot stars and through triangulation, come up with a present position. This system was designed to do that entirely automatically. It knew all the stars, the ones that were shooting anyway. It could calculate where the stars were and start looking around the sky, day or night, and start finding those stars and actually computing your present position. And then when you know where you are, you can figure out how to point the pilot where to go. So we were a great team, me and R2-D2. And here's looking at the top side of the airplane. The two hatches are closed there, the pilot and the back seater, and right behind it's a piece of glass, if you can kind of see that. It's actually quartz, because of the intense heat generated on this airplane. That used a very highly refined and precisely ground piece of quartz for that telescope to look out to the sky. And so we had aligned it in our hangar. So we're up in Northern California, right north of Sacramento. Usually have nice weather up there, except in the middle of the winter. And you'd line it and you taxi out from underneath the hangar. And within, within 30 seconds, it was already tracking 3 stars. It would do this in the middle of the day or at night, it didn't matter. Thinking, well, how do you see stars in the middle of the day? Well, a telescope can look right past the sun and see the stars, and automatically lock onto these stars to start computing your position or keeping track of your movement as you're moving, keeping track of your position. And this system is so good, it can keep us within 300 feet of track. This is all way before GPS, you understand. We take this for granted now. But by shooting stars the way Magellan did to navigate around the world, and as I learned as a navigator student, that's a pretty phenomenal performance for an aircraft doing as much as 2,200 miles per hour. And it was extremely important because we flew in very sensitive parts of the world, and we were pressing close to people's borders. We had to be that accurate. So officially, the Northrop ANS-8, built in 1963, and flying off the way our ancestors did, navigating around the world. Okay, I spent 465 hours this is my favorite office I've ever worked in. And like most people, I had absolutely stupendous time flying in the best airplane in the world, in my humble opinion. And I think Jerry's going to take the stick now and tell you about the front seat, and we'll both be around for questions after that. Thanks, Jerry.
BC and Barry, raise your hands, please. BC is the high-time pilot, and Barry will be doing the presentation on Sunday. But my autograph is worth about $1. BC's worth about $25, so go to BC and get his autograph. Okay. And I think BC, I'm sorry, but I put $12.50 there, but I think was it $12.38? I'm not sure. I'm sorry. Okay. And then his backseater, JT Vita, was the high time with about 1,350 hours in the airplane. And unfortunately, JC is no longer with us. He's no longer with us. Okay, well, Jerry's going to keep the pointing end forward. And, you know, if you have a burning question, you can raise your hand. We want to be succinct because there's going to be another presentation. But it's interesting that you're so busy. And, you know, after this, BC can answer his questions. He was my instructor. And as I said, I used to hate him, and then I loved him when crap happens. I lost an engine in Mach 3, and all of a sudden, everything in the simulator in a right turn with a right engine, and personally, crap was happening, and all of a sudden, you know, everything that BC showed me in the simulator kind of worked. Not everything, but most of the stuff worked, and we made it. We just made it through stuff, you know. Okay, there's the front seat, and guess what? It's all steam gauges. You think it's going to be a glass cockpit, you know, it's going to be all, but what's the problem with glass cockpit? It's temperature. It's all analog, it's all steam gauges, and the first time at Palmdale when I jumped in the airplane, I was kind of shocked. I thought it would be high-tech stuff, you know, but no, it's just analog stuff, dials and whistles. So what we're going to do is, you know, this is the A12. Okay, I'm going to go back for some quick question. This is the A12 cockpit. Look at that piece of mess. There's the SR cockpit. There's the A12 cockpit. And I think, BC, they put just stuff where they wanted to put them. Is that true? They just put gauges. Galley put a gauge. And when I sat in the cockpit in Mobile, I said, you know, do I really want to take this airplane up to Mach 3.2 and not have the safety items and the switches in the right place? And it was really, I said, we had a lot of respect for the A12 contingent for the risks that were taken to make our airplane a hell of a lot better. But some of the inlet problems that, you know, it was just hit or miss, let's go fly it. There were no computational flow, no wind tunnels were not very good. It was just a hit or miss, and we had a lot of respect after sitting in that front seat. Okay, we're going to go through it, and basically we'll start here. Unfortunately, the Dayton Museum has restricted their 360, so we've made some good resolution. We're going to zoom in, and I think it's almost going to be better than the one at Dayton. But we're going to go around the cockpit, and these are the primary areas. We'll go around from the radios to the environmental, to the major instruments, to the engines. Whoa. Sorry about that. To the side panels. And we'll start with the left. When you look at the canopy rail, I can put my left arm on the canopy rail, and that's it. There's the ejection seat. I'm sorry am I in the way here? Are you okay? Okay. There it is, and it's kind of simple. There are not many lights in the airplane. We have a beacon and a tail light, but it's mainly internal lighting. We don't have a red, green stuff, you know. It's basically a black airplane with no lights. And that's our lights. We have a couple of switches. There's the UHF radio. The front seat's got a UHF VHF system. The back seat has a UHF secure code and a HF system. Correct, John? From John's perspective and his presentation, can you understand why I think that the backseater is the commander? Can you meaning I'm so busy and he has the big picture. Sometimes you get a little confused. Is it DP28 or DP37? God, you know, it's a right turn, and you look at the map projector, and sometimes you're so busy. No, Chair, we're coming up on DP27 and it'll be a right turn and we're still doing 3.0. So he's the secure link to make me feel really neat that I'm doing the right job. And that's why I think it's the commander. Okay, there's the oxygen systems. So we have 3 separate oxygen systems. I get a comment sometimes in presentations, where's the liquid oxygen for your airplane? Because it's really a rocket. Well, yes, we have liquid oxygen, but we're breathing liquid oxygen. Remember, it's still a jet engine. It's breathing air. It's taking air at 80,000 feet and pumping it in and pumping it out the back end. It's an air-breathing vehicle. There's the oxygen systems. Okay, here's you can see the lower left here. There's the throttles, and for some pilots that's a speed brake switch here, but that's a double restart switch. If we have a major emergency, we can take this switch and run both of the spikes full forward and put the airplane in a more secure mode. So that's called a throttle restart switch. That's a very special, it seems innocuous. The back 2 switches are aft doors. Supersonically, there are 2 sets of doors that run the inlets. The forward doors are 98% of the time run by the computer. We can take them manually. But the back doors, we can manage those doors manually. And it has to do with efficiency. Some people manage them a little differently, but the back doors, and we don't have a good laser, my astronomy laser will not work on this one here. But these are manual back doors. And these 2 switches seem very innocuous, but the pilot can do minor maintenance on the engine. I can up trim and down trim the engine manually, so I can change the temperature of the engine if I see something I don't like. So I can leave it in auto. It runs about 805 degrees, but if I want to change that, I can use these 2 switches right here, and I can up trim the engine and I can down trim the engine. So I can do some minor maintenance during flight. See if that works. Wait a minute, go ahead. See if it works. Mine doesn't work. No. Yeah, it's not. No, it doesn't work. Yeah, okay. Even my astronomy laser will not work on this screen. Okay, John mentioned the map projector. I can do it in auto or manually. That's a little switch. And John's exactly right. It's just a map. It's on a roller. It's a 1960 map, and it just sits there and rolls. So I have a perspective of where we are to keep track. Because when you're going through 30 turns, this is turn 16, turn right 270, still doing Mach 3, and then you come up to turn 19. There's maybe 20 turns to go, so you have to be really careful. Never lose track of where you are. That's the key. That's the key. Never lose track. Okay, those are the switches, aft doors, and the gas temperature. There they are, EGT, and our aft door selector. Okay, we're going to come to the left side, which is basically environmental. The plane is so good, at 800 degrees, I can blow snow in the back seat. If we go to full cold in the air conditioning system, you'll say, no mas, no mas. That's how good Pete Law designed this system. You can blow snow in the cockpit, and the front pie plate is 600 degrees, and you're blowing snow in the cockpit. Okay, let's see what we have. That's our cabin altimeter. We fly at 26,000 feet, so we're breathing 100% oxygen all the time. We can go to 10,000, but we want to use the air to cool the front of the airplane. If we go to 10,000, a lot of air is used for the cockpit. So basically, when you look at this airplane, from right where the star is, back, we let the airplane to its own demise. We don't care about the temperature. From the star forward, which is the chine, inside this chine area where you see all the sensors on both sides, we try to keep that below 140 degrees. 140. We get above 160, we get a little concerned. But this entire system, the front of the airplane in the chines is cooled down to 140. Behind this notch here, we don't worry about the temperature. We let the temperatures go up to 3,400 degrees at the exit. So cool in the front, don't give anything in the back, but we want to keep the chines below 140 degrees to have all the equipment survive. Can you imagine what the thermal problems are with the airplane in 1963? Thermal problems were astronomical, trying to keep this thing cool. What's the cooling fluid? Come on, guys. Fuel. We want really cold fuel, and we heat the fuel up. We go through fuel heat exchangers, and we take that hot fuel and blow it out the back end. Fuel is the cooling system for the airplane. And as the airplane loses fuel, what happens? And you can sense it in the cockpit. You can sense the plane getting a little hotter, getting a little hotter. The cooling system is working a little higher, working a little higher. Okay, there's our temperature gauge. That's our compressor inlet temperature, and that's the temperature the engines are sensing. And remember, it's can get up to 427 centigrade, or about 800 Fahrenheit. That's not the exhaust temperature for the engine. That's where the compressor is sensing 800 degrees. That's the penalty for compressing air to run the engine. We get up to 16 pounds per square inch at speed, but the penalty is the temperatures are astronomical. Okay, that's a cool gauge. That's a compressor inlet pressure gauge. What's the pressure here? Come on. Okay, 14. How about 15? Round it off to 15. Okay. At 82,000 feet, it's 0.4 psi ambient. The inlet is so efficient, we're putting 17 pounds per square inch into the engine. 0.4 psi outside, 17 pounds per square inch inside, and the engine wants more. The engine thinks it's 3,000 feet underground, except for what? It's not minus 62 degrees. What is it? It's plus 800 degrees. And the engine says, I don't see a problem. Do you see a problem? I don't see a problem. It just runs. It just runs. Okay. Oh, John mentioned a TDI gauge. Okay. Well, you see there's an airspeed indicator, there's an altimeter, yada, yada, yada. And supersonically, compressing air has problems, so we really don't use any of those gauges supersonically. We use the triple display indicator. And it has Mach, keys equivalent airspeed, and at times there's about a 120 knot difference between what we're doing and what the airspeed indicator is, So it's the era of compressibility. And so we use the TDI indicator, religiously use the TDI indicator. Okay, here's our inlet controls. And we love the inlets to run automatically. Terry, maybe 95% of the time they do, about that time. Every once in a while, we have to take an inlet or a spike, and all these gauges here tell us we can manage the airplane at 3.2 or 3.1, and we can manage the aft doors. But I would say would you say that about 95% of the time, the inlets they're cruising. What is it? It's 1963, guys. And the A-12 was the vehicle that really did all the testing to make this work. We had a lot of respect for those guys. Okay, here we go. Below me, between my seat, between the stick, how many people touch the stick? How many people have you touched the stick? What do you think? Just like dancing with a woman. It's perfect. It's absolutely perfect. Can I ask you what the checklists are? It's really important. Okay, I'm very sensitive. We want to make sure we get, I'm very sensitive about that. We have caution and warning lights. There's when we had the digital system, we had 3 computers. Those are the reset switches. We've had failure subsonically and failure supersonically, and sometimes they reset, sometimes they don't. That's the computer reset between my legs. There's 49 caution and warning lights, and you got to know where they are, and you got to know what they do. There's a alternate gear release here. We limit the rudder. We have a rudder limiter when we take off. We want to limit the rudder displacement, about half BC, about 50%. Yeah, 50%. We limit the rudder travel mechanically by moving a latch. Okay, that's the heads up. There's our angle of attack. In my view, of critical gauge. We're not flying this way. We're flying at 6 degrees. The airplane is on this bow wave. It's flying at 6 degrees angle of attack at speed. It's really unusual. And you can manage that, get it a little lower. The lower the angle of attack, the more efficient the airplane gets. We have our attitude indicator. And those 2 bars there, I know we haven't got but these 2 bars here, the vertical bar is a track bar. So when John is managing, and R2D2, and we call him R2D2, we want to put a blue stripe around it. the airplane. When that track bar is centered, I know the Astro Tracker is working perfectly, and John is not going to make any comments. Even when I make a turn, if I make a turn, the vertical bar will sit there and fluctuate a second, and as soon as I roll into a 35-degree bank turn, the bar will center. And you know what I know in the front seat? I am plus or minus 300 feet exactly where the Astro Tracker wants us to be. The horizontal bar is a pitch bar. Every 1 degree of pitch at Mach 3.2 is 3,600 feet per minute. So you don't make a 1 degree pitch change. We're dealing in, with a wheel, we're dealing in 20ths of a degree, very minor pitch changes. So we level off at maybe 73, and we enter a little cruise climb. Every 4,000 pounds of gas, you're climbing about 1,000 feet. But pitch is very sensitive. A 1 degree pitch change at speed is about 3,500 feet per minute. Very minor pitch changes. What's the airplane designed to do? Go straight level, real fast, one time over the target and not come back. That's it. That's it. Okay, that we don't use at speed. That's an airspeed indicator. It could be as much as 120 knots off due to compressibility. We don't use the altimeter because it's an error. We don't use the vertical velocity very much. We use the bars, and we use the triple display indicator. Keys, altitude, and Mach. And if you're in the simulator, if you're flying at 2.99 Mach, and the task is to fly at 3.00, guess what? If you can fly at 2.99, you can fly at 3.00. If you accept 2.99, that's not good enough. I don't want to see 3.01. I don't want to see 2.98. I want to see 3.00. And that's what the training is all about. We're so well trained. I think, Terry, can you mention the RPMs and stuff still? Almost, right? You can mention the RPM, the engine RPMs. Yeah, well, we're really well trained. I mean, we really are. Okay, there's the TDI indicator. Okay, oh, there's the bar centered. So if I know that, I'm perfectly level, and if that vertical bar is on track, I know that John's Astro Tracker R2-D2 in the back seat is doing its job, and what I know in the front seat, I am within plus or minus 300 feet of where I'm supposed to be, anywhere in the world. Anywhere in the world. Okay, that's a horizontal situation indicator, meaning my horizontal space, and when this bar is dead center, I know, so I'm on track. So the vertical bar and this bar tells me in the front seat, I'm right on track where I'm supposed to be. That's my goal there. Okay, to the engine instruments, RPM, the fire lights, two fire lights, and you think these are digital gauges. The EGT indicators are just counters. They're just rotary counters, clicker counters. There's not a digital gauge in the entire airplane. It's all steam gauges or counters, and there's a reason for that. We go down. We have I'll just put here. We have nozzle indicators, fuel flow, pressure, hydraulic pressures. Fuel flow is interesting. We burn 5,000 pounds of gas starting and taxiing out to the end of the runway. We burn 2.5 tons of gas to get to the end of the runway. We burn another 2.5 tons, 5,000 pounds, to get to 25,000 feet to get to the tanker. So we taxi out, we take off, we get to 25,000 feet. We've gone through 10,000 pounds of gas. The fuel flow for each engine at takeoff is 75,000 pounds per hour per engine. That's 150,000 pounds or so. That's about, divide that by 6 or 7. We're burning 6.5 gallons a second rolling down the runway. So fill up your car in what? About 3 seconds, and it's gone. We're burning over 6 gallons per second as we light the afterburners and start going down the runway. It's a terribly inefficient airplane subsonically. At speed, it's better than a 727. We're burning about 19,000 pounds per hour at Mach 3.2. We're burning 19,000 pounds per hour. It's an incredibly efficient airplane at speed. Why? Right there. It's the inlet system. It's the inlet system. Okay. Here's our fuel, and John said we take on 82,000. And remember that fuel, why do we do it in pounds versus gallons? Come on, guys. Why do we do things in pounds and not gallons? It's density compensated for. I came back, I had a mission back in December from Okinawa back to Beale, and we saw the tankers 300 miles away. It was so cold. The tankers are orbiting, and the fuel was so cold. I got over 82,000 pounds of gas on the airplane because the fuel was so cold. We're sitting there and, oh, we got 79, we got 80, we got 81, we got 81.5, you know. And it was so cold. It was really fascinating to, you know, see, you're descending from 80,000 feet. You look out 400 miles and you almost see these little whiffs. And you say, holy crap, there they are. The tankers are ready for us. They're ready for us. It's kind of fun. But we have 82,000 fuel selectors. We can select tanks. We can transfer fuel. The Concorde does the same thing. The Concorde manages its efficiency by transferring fuel. We can aft transfer and forward transfer. And we want to have a CG that's within the limits. And that's what we do. Here's our CG gauge. The A12 did not have a CG gauge. And it blew me away. I didn't understand I don't understand why they didn't have a CG gauge. But here's our CG gauge. Fuel tank pressure. The fuel is JP7. There's a high flash point. And why would we pressurize the tanks with nitrogen? Why would we do that? Why would we carry so much nitrogen on board the airplane? Any thoughts? Liquid nitrogen. And it becomes the limit of what we can do. Any thoughts? Go. We're inerting when we burn the fuel is about 320 degrees. And we don't want the tanks to blow up. If you use JP4, it will just blow up. So we pressurize the tanks. We turn the liquid nitrogen into gaseous nitrogen, and we pressurize the tanks. We inert the tanks so they don't catch on fire and blow up. What year is it? It's still 63. Come on, guys. Okay, there's our CG gauge. As a fuel flow, I always used to like the fuel flow. You get to the end of the runway, you go from 0 to 400 keys at the end of the runway. We go from, in 2 miles, we go from 0 to 400 plus knots. And you look at the gauge and I go, holy crap, 75,000 pounds per hour. I go, it's just amazing, you know, when you think about it. And you go and you roll out and you know you've gone through 10,000 pounds of gas just to get up, to go to the tanker. Yeah, it's quite fun. Okay, there's the gauges. Oh, here's my map projector. Here's my great digital map projector, which is a rolling map that they made. They pasted together, and it just sits there and rolls on rollers. And I can manage it, or I can do it automatically. But that keeps me on track. Meaning, if I get confused, every once in a while you look at the map projector. If you have a lot of turns, you know, I'm coming up on turn 37, and the back set is this. So you look at the map projector and you say, okay, I'm back on track now. Okay, on the right side, there's our liquid nitrogen. We have fuel shutoffs. This is our electrical system. It seems simple, but it's very complex. And I was in the B model, and these two here were quite annoying. On is down. Emergency is up. So I'm on my second ride in the B model, and we're on external power, and the crew chief says, generator's on. Well, you know, the engine turned my left generator on. What did I do? I turned the left generator to emergency. Don't do that again. On is down. Why is on down? On is down. That's how they designed it. So you have to remember, on is down. There's our CG gauge, fuel tank pressure. Okay, that's what the simulator looks at night. That's our 4-hour torture chamber. And at night, it's quite exciting. You know, it's really, we have a little periscope, and when you light the burners, I mean, the RSO can look sideways and down. I can look sideways, front and up and back, actually back. We have a periscope, and it's always impressive when you're in maximum burner, especially at night, to see these 2 gigantic torches behind the airplane. And at the end, there's this little flicker. You see this little flicker. And you get mesmerized with the colors until the airplane says, "You're looking outside. Be careful." But every once in a while, you look at the periscope and you see these gigantic flame torches out the back of the airplane. And you realize this is pretty cool to be going at night in Mach 3 and blowing gas out the back end of the airplane. It's really exciting. But that's what it looks like at night. And remember, if you don't pass the simulator check, what, Terry, do you fly the airplane? No, you don't pass the sim check. And we've had people who didn't make it because, you know, then some pilots, I don't need to have a simulator. I just give me the airplane and I'll fly the airplane. That's not how it works. You don't pass, you get 300 hours in the sim. If you don't pass the sim check, you will never fly this airplane. That's it. No debate, no discussion. That's the rule. That's the rule. Okay, we went from here to there. The key instruments, over to the engine instruments, over to the electrics and fuel. We got, sorry about that. We're going to go over here to the last one, and basically, right side, this is me, this is our, let me just zoom in here a little bit. There's our electrics, which I just showed you. And now, the right side, this is our stability augmentation, and we can engage stability augmentation. This is our pitch wheel. When we engage this, we don't use the stick and pitch. We use this pitch wheel. Everybody has flown the airplane, everybody has flown the airplane at 3-point Mach at speed. It is a beautiful airplane to hand fly. There's a little difference between flying it at speed and flying it supersonic, but not that much. And think about it, the plane's going to expand about 4 inches. What are the cables going to do? You would suspect that things would be different, but it's not. The cables are precisely tuned to the expansion coefficient of the airplane. So you can hand fly the airplane beautifully at Mach 3. And the airplane is a gorgeous airplane to fly subsonically. It's a beautiful airplane to fly. The stick is feeding you back. You can look at the instruments, but you know what the airplane's doing. Why? It's a cable-controlled airplane. It's not a side stick controller. It's not electrics. It's a cable control. From that front seat to the back, there's 2 cables that run the flight controls. Stability augmentation. I have my VHF radio, my nav ILS, VHF ILS. Go, my radios. This here is a new one. When did, let's see, it's called a PDD. We had a laser line. We were concerned about flying at night, that we needed a better system for horizontal situation awareness. So they put a red laser there, so we could adjust the red laser, and the red laser would run across the entire cockpit. I would have loved to have a blue laser to feel a hell of a lot better, but at that time the energy levels for blue were so high that we couldn't use it, so they used the red laser. Unfortunately, when you rolled into a turn, when you rolled into a left turn, BC, what illuminated? The fire lights. If you didn't cover the, let me see if I can go back here a second. Oh, no. Sorry, I apologize. No, I'm sorry. There we go. If you, no. Okay, I made a mistake here. If you roll into a turn, if you didn't put the covers on the fire lights, the laser would run right through both fire lights. So I was on a night mission, and I forgot to put the covers down, and I rolled into the turn, and all of a sudden, bing, bing, I went, and I realized the laser is running through the fire lights, but it was a red laser, and I think it was pretty valuable because you got a more comfortable feeling than just looking at the ADI that you were horizontal. It was a pretty good system. Okay, but that's it. I mean, it's all steam gauges. It's all steam gauges, and we were so privileged. BC's got the high time for the B model. I spent a lot of time in the B model. We've all had our great missions. We've all had our screw ups. We've all had our memorable experiences. I flew one mission where I saw 3 sunrises and 4 sunsets in the west on one mission. 3 sunrises and 4 sunsets in the west on one mission. And I mean, you never get used to the colors, the indigos and the blues, you know, the sunrises and the sunsets. But you have to remember, you're flying the airplane. flying the airplane. Okay, guys, we're going to be around. There's going to be another symposium, but just remember, what year is it? It's 1963. Can you imagine a team doing this? Do you think this could even happen today? I would say no. I would say no. They were sworn to secrecy. Everybody knew what they were doing. Do your job. And it's kind of the Yoda. I have a Yoda slide. I teach at a school, and the Yoda slide is, do or do not. There is no trying. Don't tell me you're trying. Go and do. And this whole program was a Yoda go and do. And we were so blessed to fly this airplane, because guess what? 15,000 miles, minus 60 degrees behind the tanker, right? Up to 800 degrees, an hour at Mach 3, or 3.15, down to the tanker, minus 60 degrees, up again 5 times. Come home, what? Maintenance. How'd you go? Yeah, upstart, oil pressure gauge fluctuated, top 2 circuit breakers, the oil pressure light came on for a second. I had to pee in my pants, but that was okay, And everything worked. And that's just, we never cease to be amazed every time we jumped in the airplane. How blessed we are. Absolutely blessed. Thank you.